Hello everyone, welcome to today's class. Today we shall discuss about structure of atom. In the previous class we have already discussed regarding the discovery of protons and electrons. Today we shall discuss regarding more about this chapter. The discovery of electrons and protons made by Thomson and Goldstein along with their co-workers brought a revolution in the field of science, especially in chemistry. And electrons and protons were regarded as the main particles which are present in every atom. So now the major challenge in front of the scientists was to determine the relative position of these particles in an atom. That means where actually these protons and electrons are present in an atom. That was the big question. So let us learn briefly regarding the models of atom in today's class. So J.J. Thomson was highly encouraged by the discovery of electrons, and he was the first person to predict the picture of an atom known as Thomson's model of an atom in the year 1899. And what was his postulates? What he said, that an atom may be regarded as positively charged sphere in which protons are present and electrons are embedded in it, which are negatively charged. And finally he said that positive charges due to protons and negative charges due to electrons balance each other. As a result, an atom as a whole is neutral. This was the postulates which were given by Thomson. And you can observe this picture was given by J.J. Thomson, and he said that whole atom is like a positive charge in which protons and electrons are present in it. And he also compared an atom like a watermelon in which seeds are like electron in it. And he also compared it with cake, plum cake or pudding cake in which uh, dry fruits are like electrons and the whole cake is like a atom. And he finally said that atom is neutral. But the J.J. Thomson's model of an atom could explain the main characters of the atom at that time, but he did not have any experimental support. So therefore it was opposed by his co-scientists and was rejected. But his prediction that an atom is electrically neutral and has no charge is still acceptable. So this was the model made by Thomson. But later on, a famous scientist, the major contribution that is given by a famous scientist whose name is Ernest Rutherford, who is from England, he performed a famous experiment, that is alpha particle scattering experiment, in the year 1911. Gave a major structure of or model of an atom. So what was his experiment? So Rutherford selected, for his experiment he selected a thin foil of heavy gold metal which was about 1000 atoms thick, and he bombarded the same with high speed alpha particles. Bombarded means he hitting of alpha particles to gold metal. So what do you mean by these alpha particles? Alpha particles are nothing but positively charged helium nuclei. Nuclei is the plural form of nucleus. And alpha particles were first passed through a fine slit and then made to strike against the gold foil. And these alpha particles got scattered and produced bright flashes on circular screen coated with zinc sulfide. So let us learn using this picture. You can see that this was the setup made by Rutherford. It was a famous experiment and shown by Rutherford, that which we are still accepting his model structure of an atom. So the first is the source of alpha particle, that the box which is there, inside which he took a radioactive element, that is radium, which is enclosed with a lead box. And in using that radium, he passed the alpha particle through a small slit you can observe in that picture inside the box, and he made to fall out on a thin gold foil. Gold foil you can observe inside that circular fluorescent screen, and this gold foil is about 1000 atoms. It contains only 1000 atoms. Such a thin gold foil he took. You know that why he took gold foil? Because gold is a highly malleable uh, metal, and it was circular and closed with it was not fully closed, and he took a circular fluorescent screen which was coated with zinc sulfide. And why? To get the bright flashes. When the experiment took place, he wanted to see the observations, what happens actually. So those reflections could be visible when zinc sulfide is coated on this fluorescent screen. And when he passed the alpha particles for his uh, observation, you can see that blue color line which is passing through the gold foil, there were most of the particles which were undeflected. Without deflection, they passed straight path. And here there were few alpha particles which were scattered with 4 small angles, and you can see the deflected backside. The pink color rays are the major deflections that he could observe. So from this experiment, what he has observed, what was his observation? That most of the alpha particles were able to pass through the gold foil undeflected, without deflection. And some of these particles were deflected by small angles, and very few alpha particles, say 1 out of approximately 12,000, suffered major deflections and even came back in the same direction. That means, observe this picture, children. In the A picture, first picture, you can observe that most of the alpha particles, they are passing through the gold foil. In the fluorescent screen, you can observe that two deflections you can observe, that is major deflection. In the second picture, you can observe that these are the atoms of gold foil, and a few got deflected backward, and very few deflected in a small angles. If you observe this picture clearly, you can see that the first atom, these atoms, the yellow color, are nothing but atoms of gold. Small particles are nothing but alpha particles. When they hit on an atom, a gold foil, when these particles got a chance to hit near the nucleus, come to near the nucleus, they deflected in the small deflections, small angles. You can see in the first atom. In the second atom, that also deflected a little bit larger when it come very closer to the nucleus. The third atom, you can observe that when an atom come exactly at the place of nucleus, it has turned back. What was this? This shows that why it has happened, why these deflections are possible. You all know that in the beginning itself, I told that alpha particles are nothing but positively charged helium nucleus and nuclei. These particles are positively charged. When they come near the nucleus, they got deflected, and this shows that inside the nucleus there should be positive charge or positive particles. And finally, what he concluded by this, and he said that as most of the alpha particles pass through undeflected, this means that they do not come across any obstructions in their path. Observe this, children. The particle which is coming from the alpha source, alpha particle, that is passing undeflected, that is because it is not come across any obstruction in its path. Very few got deflected because they came near the nucleus of an atom, and 1 out of 12,000 got deflected back. You can see the third one, which is deflecting backward. That is because it has come across with a nucleus inside it. So as he told that a few alpha particles suffered a minor deflection as a very few major deflection. This means that they must have met with some obstructions in their path. So finally, what was the features of Rutherford model of an atom? Finally, what he said regarding this, he said that an atom consists of two parts, that is nucleus and nuclear portion. That means nucleus present in the center and it is surrounded by extra nuclear portion. So finally what he discovered the nucleus. Rutherford discovered nucleus. You know that children, J.J. Thomson discovered electrons, Goldstein discovered protons. Rutherford, by his famous experiment, that is alpha particle scattering experiment, he told that nucleus is present in an atom. So nucleus was discovered by Rutherford, and he told that the mass of the atom is mainly of the nucleus, and all the protons and neutrons, which was discovered later by Chadwick, and are present in the nucleus, because Chadwick was discovered later after Rutherford. Discovery of nucleus was done by Rutherford first, and discovery of uh, neutrons were done by James Chadwick later on. So he told that inside the nucleus protons are present, and around it all the electrons are present in the extranuclear space around the nucleus. So the electrons present in the extranuclear portions are not stationary. These are revolving around the nucleus at high speed with a circular path. And finally he said that the revolving electrons do not come close to nucleus and drawn towards the nucleus because their force of attraction towards the nucleus is balanced by the centrifugal force. So these were the features made by Rutherford. So in today's class you have observed the models of an atom, or they gave the picture or the positions of protons and electrons. And finally Rutherford's experiment was strongly accepted by most of the scientists. But what was his limitations? Means he didn't said regarding the electrons distribution. So in the next class we shall learn about distribution of electrons in the nuclear portions. Okay, thank you children.